Vitalik Buterin, the founder of Ethereum, stated that ZK SNARKs are perhaps the most powerful cryptographic technology to come out of the last decade. So today, we'll cover what the hell zero-knowledge proofs and ZK SNARKs are in 5 minutes so you can make it. Let's start with what the problem is. Authentication. What is authentication? It is essentially confirming the truth of a particular piece of information claimed to be true by another entity. And authentication can be messy. Consider an example where you are logging into your Gmail. You, the prover, must supply a secret, your password, to the verifier. The verifier, Google in this example, will attempt to match your password with what's in their database. So, what could go wrong? Number one, since you provide proof of ownership of your account through your password, a malicious actor could intercept traffic between you and Google, obtain your password, and impersonate you. Number two, since Google holds a database of all passwords and malicious actors could steal the database and pretend to be any prover from the database. There are a couple solutions to this problem, but today we will discuss zero-knowledge proofs. Zero-knowledge proofs were first described in 1985 by Silvio Macaulay, Shafi Goldwasser, and Charles Rakoff. They must satisfy three properties. Completeness, ability of a prover to demonstrate knowledge of information with high probability. Number two, soundness. A verifier must be able to determine with a high probability whether or not the prover is actually in possession of the information. Number three, zero knowledge. If the information is true, the verifier must learn nothing more than the fact that the information is true. Now, if all that sounded like mumbo jumbo, let's walk through an example. Imagine a scenario where two fishermen, John and Jim, have a certain number of fish and want to determine if they each have an equal number of fish. To compare the number of fish without sharing the actual number, John has 3 different locked storage bags. He puts a label in each storage bag that either says 2, 3, or 4 fish. Next, he throws away all the keys to the storage bags except the one that corresponds to how many fish he has and leaves the scene. Jim arrives and has 3 different marbles: red, green, and blue. He puts the red marble in the storage bag with the number of fish that he has and the other marbles in the other 2 bags and leaves the scene. Wanting to know if him and Jim have the same number of fish, John comes back and opens the storage bag with the only key he still has and looks for the red marble. If the red marble is in the storage bag, hooray, John and Jim have the same number of fish and can celebrate together. However, if John finds any other color marble, he knows that him and Jim do not have the same number of fish and has no idea how many fish Jim has. Jim returns and sees that John has picked the storage bag with the green marble. Thus, neither John or Jim know how many fish each other have. They just know that they don't have the same amount. So what are different types of zero-knowledge proofs? Number one, interactive. Interactive zero-knowledge proofs require the prover to perform a number of actions to convince the verifier of the certain information. The transferability of interactive zero-knowledge proofs are limited. In order for a prover to prove the information to others, he must repeat this entire process. Number two, non-interactive. In non-interactive zero-knowledge proofs, a verifier can be replaced by a hash function or something similar, and the result of the hash function is the challenge. Consequently, the prover and verifier do not need to repeatedly interact with each other, as the proof exists in the message the prover sends to the verifier. ZK SNARKs, a type of non-interactive zero-knowledge proof, is and will be implemented by teams in the crypto space. ZK SNARKs stand for Zero Knowledge Succinct Non-Interactive Arguments of Knowledge. I know it's a mouthful, but they have 3 important properties. They are zero knowledge as they don't reveal any additional knowledge to the verifier other than a particular piece of information is true. They are succinct since they can be verified very quickly. And they are non-interactive since repeated interaction between the prover and the verifier is no longer necessary. ZK SNARKs are implemented by Zcash, a privacy-focused cryptocurrency. They enable 2 very important applications for blockchains: scalability, and privacy. Zero-knowledge proofs are being used all over by Layer 2 Ethereum scaling solutions like ZK Sync and Loopring, to name a few. There's a lot more to cover here, and I plan to continue to cover this in upcoming videos. Please comment below if you would like me to cover anything in specific, or if you just enjoyed the video. Thanks for watching.